Hi everybody, thanks for coming to my talk, and especially thanks to Karthik and the NGINX team for having us here. It's my first conference talk, so I'm pretty excited to tell you about our journey from migrating our old API gateway from Apigee to an NGINX-based solution. And to start off, we're all going to level up and learn something. And the first thing we're going to learn today is some German. So we'll say Moin, which is the northern German way of saying hi. So when you're in Germany, just say Moin, everybody will understand you, and that will be a nice icebreaker. My name is Felix. I'm an enterprise architect with Mobilcom-Debitel. When I'm not working, I like cooking and sailing, even though I get to sail not that much at the moment, and do stuff IT guys like to do. The last thing I did was set up a Kubernetes cluster on my home server, so I'm a little bit geeky sometimes. If you want to reach out to me, feel free to contact me on GitHub or write me an email. The company I work for is the brand of the Freenet Group positioned as the telecommunication and service provider, which is Germany's largest service provider for mobile telecommunication in Germany. We offer to our roughly 12 million customers data plans, telecommunication plans, and all other services around digital lifestyle and television. We operate roughly 550 shops, and all that is powered by more than 250 different IT systems. I bet you know that from your enterprises, that when you have a company that grows for a lot of time or a long time, you end up with quite a mess, actually. The topic I want to talk about today is APIs, of course, since we are on the API management track, and the API rises. I joined the company in 2014, and by then we were all in the API strategy program. And in 2012, my company decided that it would be good to integrate APIs more and more into our really diverse architecture. And our CTO envisioned more of a company-wide API, since we had many different IT systems, which all had their own APIs. We wanted a complete solution with one data model. It should all feel the same throughout many different APIs. Of course, that's a really hard task to achieve. But that was the beginning of our API strategy. And APIs should help us to increase the integration velocity, not only between our own applications, but also between our applications and the applications of other companies we partner up with. And also to allow us decoupling in between our systems. And for us, the core element of our API infrastructure was, of course, an API gateway. As you might know that from many different API architectures, an API gateway is almost always in place. And to speak of an API gateway, you will always need to focus on the use cases you're trying to solve. And for us, I want to start with the basic use cases, which we think of as the core use cases of an API gateway, which in its core is usually request routing, so the usual reverse proxy use cases, traffic monitoring, so that you know what's going on inside your API architecture. Authorization is a really important topic. I'll focus on that later a little bit, how we did things. Tracing is important so that you know when things go wrong, what went wrong and where in your architecture it went wrong. That's important. And to achieve that, we settled on an API gateway, and Apigee was our initial choice. It was back in 2012, and everything I tell you refers back to the time we integrated the API gateway and back to the time when we adopted NGINX. In the following slides, I want to talk a little bit about API management, because let's make a quick show of hands. Who of you knows Apigee? or has heard of at least. There are a few. I won't. Miguel will try to sell you NGINX, I won't. API management. We have our core use cases, as we've seen before, but we have additional use cases that API management, in our opinion, tries to solve, which makes the whole idea of APIs more complex and more difficult to achieve, basically. In our opinion, API management is the conjunction of API gateway use cases and API economic use cases. So if you want to get more out of your APIs as a business, you will always need to focus more on the API management use cases. You'll find use cases like monetization. So the good example for that is the classical weather API. So if you're a company offering weather data and offer that for integration of third-party apps or something, you are likely to provide an API and sell API requests and request volume to others and make money out of your API. You see the API as a product, so if you build your business around APIs, actually, you will always end up in sort of an API management direction. Orchestration is almost always very important in any use case if you deal with APIs, so you always need to know what APIs you've got out there, who's using them, who can use them, what APIs are having problems monitoring stuff. API customer management is also really important. So we've spoken about the monetization aspects, and of course you will want to know who is using your API products, and of course how much can you charge your customers. You have developer portal use cases. So most API management solutions will bring a developer portal. You have developer management so that you can bring your API customers together with your API producers. And all those use cases usually end up in a single platform solution. Our platform solution used to be Apigee, and I'll now speak a little bit about how it ended up. Apigee, in its core, you must know that we had an on-premise deployment. That's scary.
It's because of the complex architecture.
Yeah, I suppose. So we deployed Apigee on-premise since we operate almost for every use case out of our own data center. And Apigee can be deployed on-premise as well as in the cloud, and we did the on-premise choice. It had a really complex architecture. It consists of seven different components alone for those API management use cases. And I didn't even mention the developer portal. That's not counting into those 7. So we deployed, like, you have a router which accepts a request. You have like a message processor, a message queue inside that. You've got some analytics engines in there. You've got a Postgres database set up, all in a high available fashion. And the data store of Apigee is, of course, Cassandra. So you have to operate a whole Cassandra cluster plus Zookeeper, which you will always need for that. So if we have to take a step back, think of API management, that sounds really complicated for what we're trying to achieve. We experienced unreliable updates and unreliable support that might be just for us, but we had those experiences that we all had occasions where we needed to roll back updates so that the platform would crash, and we had to figure that out, which with those 7 components, really difficult. And also where we issued support tickets, those weren't answered that quickly sometimes. And when you're experiencing problems in production, that's always bad. OpenID Connect support wasn't fully implemented by the time we integrated Apigee. They might added that in the meantime, I'm not sure. I haven't looked at the Apigee feature set in a long time. Apigee was acquired by Google, as you might know, like in 2016, which made us a little bit uncertain about that, since we had always a focus on the on-premise deployment of our applications, and we were a little bit uncertain about the strategy Google would put into the product it just acquired. And what we see now is that our uncertainty was right, since they developed their product more and more into their cloud strategy. So they integrated Apigee very well into their Google Compute Cloud, and we're not sure what's going to happen with the on-premise path. At the moment, I think they support it still, but how long will that be? And it was really complex to integrate that into our CI/CD processes. So we used, like many other companies, the whole Atlassian stack, Bitbucket, Bamboo and stuff, and we had a hard time getting those Apigee configuration management aspects into our deployment pipelines, since it doesn't natively support configuration as code by the time we use it. So in a nutshell, Apigee was, for us, too complex and too oversized for the requirements we had. I mean, if we think of those big architecture, this complex architecture, that's really made for internet scale applications and internet scale companies, which we don't are. So on the last slide, you'll see the shaming amount of traffic we're routing through our API gateway. So we had to operate 34 VMs for one logical environment of Apigee, and now with NGINX we're operating 2. So that's what we call our gateway monolith, which brings me back to the title of my presentation. It wasn't portable. You couldn't test Apigee configuration on Windows, or you couldn't run it on Windows, which most of our developers use. It was error prone because if one component had an issue, all of your API platform had an issue. It only supported Red Hat Enterprise Linux, so pay for that. It was very hard to customize, so I spoke about the OpenID Connect integration. That's something we needed to add to use it properly, and we had a really hard time bringing that into our platform by the time. Also, the Apigee deployment had an old Cassandra version. I think now it's version 4 or so, and they had version 2, so there's quite a gap. Also, that might have changed in the meantime. And we had really high maintenance efforts. From time to time, we had to invest half a human resource to maintain the API platform, whereas in a normal situation, the resource could have been invested in making value for our customers. So that's not the balance we were looking for. The main message I want to bring across is focus on what you really need. So in 2018, we took a step back, or end of 2017, we took a step back and said, do we need the setup we are actually operating? And when we look at the use cases again, we found out that we don't utilize Apigee as it was meant to be utilized. So we didn't do any monetization, since our company's business model isn't about selling APIs. It's about bringing the most value to our customers, which is you and me basically making calls every day. API as product. We didn't sell APIs, so that wasn't an option for us either. Orchestration use cases. That's a good thing. Of course, you will always need to know what you've deployed and where. API customer management, since no monetization, no customers for your APIs directly, only the developers you engage with. That's also falling apart. Developer portal, that's a great use case, which works very well together with the orchestration aspects. Of course, Apigee had a developer portal, but by the time we tried to use that didn't meet our requirements. And I'm really proud of the trainees in my company. I just made them build me a new developer portal, which we are proud to release in the upcoming weeks to the public. At the moment, it's an internal application, but they did really well and set that for us on new technological feats. Developer management, since we only develop our APIs internally, and that's also falling apart as a use case, which really boils the thing down to the basic use cases of API Gateway. And so we were looking for a solution which provided just that, just what we needed, and that as simple as possible for us as a providing team of an API platform, as well as for our developers to publish their APIs. From an organization standpoint, our developers should be able to publish APIs completely on their own, so that they don't have to engage with the platform team and to make them as independent as possible, basically. We found NGINX Plus, and we like its simplicity. Now we're getting to the bits and bytes. We're using NGINX Plus, including with the Lua module that's provided by OpenResty. We use an OpenID provider, which provides, of course, the authentication use cases, and more importantly, which is not integrated directly into the API gateway, which makes us, again, vendor independent for that part, which is really important for us. We have really simple analytics integration. I mean, you can all imagine that. Write log files, let that flow into your Elastic stack, and be happy with that. And you can include any metric you need. That was really sufficient for us. We can use a default identity provider using bare bones OAuth 2 and OpenID Connect, which is really helpful. The config management of NGINX integrates really, really well into our software delivery pipelines and CI/CD processes. So we store all our configuration in our source code management and push that out via the usual CI/CD pipelines, including testing, releasing, and that makes it really easy to operate and easy to use for our developers. Authorization is something we needed to build into NGINX, since it doesn't bring that out of the box. I'll focus on that a little bit later. And we implemented a custom OpenID Connect integration. Since by the time we integrate or built our API gateway, the reference implementation by NGINX wasn't there, as well as the NGINX controller module for API management wasn't there. So we had to be a little bit creative. So integrating NGINX into our architecture. We try to use as many components of our existing architecture as possible, so that we don't build again an island of API management which sits there on its own, but a solution that integrates well with the rest of our applications and which works basically the same as our other applications. So I stole the picture from the NGINX website. Since my PowerPoint skills aren't that evolved, I need to level up a little bit. Our architecture basically looks like that, deployed in various different environments, but in general, every environment is the same. On the edge, of course, we have an edge load balancer, which at the moment we don't use NGINX for. That's a usual hardware load balancer, not an F5 one, even though the guys are having discussions about that. In the center of our API gateway, we use NGINX Plus, deployed in an active-passive fashion using Keep Alive D, and which is directly connected to our Elastic stack for log file analysis. We have our identity provider hooked up for authentication. We use NGINX to proxy requests to our upstream backends, which are mostly at the moment legacy and SOA backends, as well as Spring Boot-based microservices for the most part. To get a little bit more into detail, we use Keep Alive D, as I said, for failover management. That turned out really well, so we didn't look into any other solutions. We didn't experience any issues with that. We use that to roll our updates of the NGINX instances to switch the traffic over. Works like a charm in like a couple of seconds, as you might know. We use Mitra ID Connect for our OpenID, our identity provider. It's an open source project, started initially by the MIT, that's where the name comes from. It's a Java-based application, which again integrates really well into our existing microservice ecosystem. So we can use the same application platforms we use to operate that. It's an OIDC reference implementation, which again helps us a lot. And the Java and Spring-based approach makes it easy for us to extend the functionality of the system and to customize that for our needs. NGINX Plus, as I said, with the OpenResty Lua module, we didn't investigate the engine script or NJS modules yet. Maybe we'll do that in the future to return a little bit more to the base. But at the moment, all our implementations are focused on the Lua module. We use the Elastic Stack for log analytics as the rest of our company, and that works really well. Our operations team always comes to me and says write less logs, so because I'm the most frequent user of this stack, and they all have full hard drives. Not my problem. The backends are mostly J2EE and JBoss application server-based services, as well as Spring Boot applications, and some Node.js applications written in TypeScript. And we operate mostly for known clients. So like, we don't have a public API which users can dynamically sign up for, like the weather API example I came up with. We mostly know our clients, our customers that use the APIs. We know the companies we partner up with, so we are always in a trusted environment. I want to now focus a little bit about what I think are the core challenges about being successful with an API gateway. The first of those is testing, because what we found out that it's really bad when you make configuration changes on your API gateway, can't test those properly, and probably blow up the whole thing. So that's not the best tactics. And of course, it's really easy to put NGINX inside a Docker container, start that on your local machine, and test the configuration you just wrote. And you can really easily make sure that the configuration you want to publish and want to use to publish your API works exactly as intended. Authentication is the first part of the authentication authorization part of things, which is really the core aspect of our API gateway. We use API keys and access tokens, like probably most of you. And for the authentication use cases, you only need to check if the authentication that's coming into your gateway is valid. So, like, is the token not expired? Is the token issued by the authority you expect it to be issued by? Or is the API key valid? But you didn't achieve any authorization so far. So, by only doing authentication, all your APIs are completely open to the public as soon as somebody stole an API key. That's of course not what you want to do in most cases. Authorization adds up on that, and what you can achieve inside the API gateway is application level authorization. So for the most part, you don't know your users, or you don't want to bring as much business logic inside. We use OAuth 2 scopes, basically, for authorization. So you're expected to see something like customer data read, invoices read, something like that, products read, or write, depending on your functionality. But you only can work on an application level. So in the API gateway, I can only make sure that the mobile app, for example, is accessing the APIs that it's supposed to be accessing. And for any further authorization, you will need context, which you usually can enrich inside the API gateway, but which would be business logic to evaluate. And what we focused on doing was keep really the business logic outside of our API gateway. Of course, you can put a lot of business logic inside Lua scripts, but is that what your intention is? Possibly not, or probably not. So for us, the user level access can't be controlled on an API gateway without implementing lots of business logic. So you might think of use cases like the customer is only allowed to see his own invoices because it would be bad if I see my colleagues' invoices or something. Or especially in telecommunication, there are high, or in Germany at least, a high amount of regulations so that only certain people are allowed to know, of course, who I've called and stuff like that. So user-level authentication is something that needs to be implemented downstream or upstream, depending on from where you're looking at. So our application level restrictions are applied inside the API gateway. Our user level are not. Authorizing users, we do that based on the characteristics. So you might have heard of attribute-based access control, and the interpretation of the characteristics of a certain user makes up their authorization. So the business logic would be to make sure that only I see my own invoices, for example. We use attribute-based access control for that, and you can ask questions like who's accessing me in person, which are the products associated to the user, which user type is it? Is it a call center agent? Is it an end customer? Is it an employee? Is it an administrator? Something like that. We use JSON Web Tokens to transport this information to our upstream systems. So when the user logs in, there's an access token issued which grants or which is forwarded to the client and which grants the access to our APIs. And we also use something we call a backend token, which is also a JSON Web Token, but which includes many more information, like, as I said, those attributes you will need. And for us, it's like an ID token, but for the backends. So we include more information like you would normally do in an ID token for the client. And since the backend token is cached inside the gateway, it's really low cost to forward it to backends so that they can build their authorization use cases upon that. On the next slide, I want to show you how easy we made it for our developers to publish their APIs. And how easy it is shows basically the fact that all the configuration fits on one slide. This is a normal NGINX location configuration, as you might know. You define a variable defining the access rights needed for this location, like example resource read in this case. You use a Lua block, call a library method we wrote. I spoke about the custom OpenID integration. We wrote a Lua module or Lua library that our developers can use, and they only need to call one method, and the magic happens in the background, and our developers don't need to care how authentication and authorization is achieved. That makes it really easy and straightforward for our developers. In this example on that slide, this location allows access with API key as well as with an access token. Of course, you can decide on, or the developer can decide which authentication mechanism he wants to use, basically. To summarize our setup, I brought up some numbers since I was asked to bring numbers, so numbers are always good. We use 5 different API gateway environments, 1 prod, and various testing stages. I bet many of you use many testing stages, and with NGINX we can really easily deploy those. This is embarrassing. We only currently have 250 requests or so per second running across our API gateway. Of course, NGINX is capable of doing much more, but at the moment, our solution doesn't need more, since this traffic is almost always traffic for our mobile apps, and that's not that much, especially since we introduced GraphQL into our infrastructure for our mobile apps. We will always make less requests with RESTful APIs. So, more importantly, we achieved a 6-digit cost reduction by using NGINX. So, by reducing the service we needed to operate, by switching the licenses, and of course by needing significantly less licenses. We can gather around 2.5 terabytes of analytics data per month. That's what those ops guys are crying about. And we can really take the value out of that. The analytics engine inside Apigee, in our deployment at least, had some problems that I don't know a single report I got successfully out of that. So we have much more success with that. We can release changes in minutes from dev to production now, since it's really fast, as you might know, to reload an NGINX configuration with no downtime, no issues at all. We have a tech support that really helps us. The best, thanks Miguel, the best thing we experienced was a bug fix, I think, on a Sunday morning. That's something we didn't expect, and that's really cool.
Was it Saturday?
Saturday?
Yeah.
Okay. Maybe with time zones and stuff. My Sunday. And I was glad that I don't have to investigate on my Sunday anymore. We migrated our 80 APIs by the time in 8 months, without any downtimes, without any production issues, throughout those 5 different stages I mentioned. So we had a lot of moving things in the infrastructure, but we managed to switch out our whole API platform to a new solution without any impacts on any client. So that was really a cool experience. Yes, and for the last slide, you should really be focusing on what your core use cases are, what you really need to empower your business. And in our experience, that's for the most part developer experience, as we've heard before. So make it really easy and convenient for your developers to publish their APIs so that they are most likely to use your solution and that they also help you to improve your solution. Testability is really a core aspect, and as you might remember, we have those active-passive deployment, and since we test locally in Docker, test in CI in Docker, deploy on the passive instance first, and then deploy to the active one, you have multiple lines of defense so that you don't get any bad code in production. Manageability is, of course, really easy since you only need to manage one single component. And you should really be focusing on what you need as an API platform team to empower your business and to make it easy for your product teams to increase the customer experience. Thanks. Do you have questions? Sorry? Not yet. I sure can send it to somebody so that you can publish it.
So are there any questions?
I have a question.
For your Lua code, are you doing anything with that besides auth? Or is it just auth for Lua or with Lua?
So we use Lua basically exclusively for the authentication part. And the only touching point our developers have with Lua are those snippets you saw. So they only need to write this small access by Lua block, and that's it basically. We had actually an issue with the Lua module since it has a really interesting, let's say, caching mechanism, which has been fixed lately, but since all our developers use the same mechanism to publish their APIs, all our configuration files have the same name, and if our developers do copy and paste, they have the same content length, and the caching key of the Lua pre-compilation was file name plus content length. So we had some weird issues where one API was accessible through the access rights of another API, and we had a really hard time figuring that out. That was the Sunday morning issue I mentioned.
So based on that, would you see yourself implementing then the authentication actually from NGINX instead of basing on Lua?
The option I see at the moment is using the NGINX module to maybe rewrite the Lua logic to bring that more to the core of NGINX. What I don't see at the moment is using the default OpenID module, since from what I've seen so far is that you've only get the authentication part with that. So you can verify access tokens, verify signatures and stuff, but you cannot easily integrate the authorization part and scope verification mechanisms I talked about. Maybe there's a good way. If somebody knows, I'll be happy to take that advice.
There is. You separate it into two different functions, but we can talk about it offline. Yes.
Great.
Yeah.
There's
More
another
questions?
question in the back.
Yeah, so I have a question with regards to. We are recording this.
Oh, sorry. I have a question with regards to a timeline. So from the time you made the decision to move away from Apigee, started your architecture, and then kind of your transition plan to your end state, how long was that
8 months
total?
total. So we had like a POC phase in 2017 where we wanted to validate if there are other options. We quickly came to the NGINX product and validated some basic use cases like reverse proxy, authentication. Was it possible in general? But the implementation and planning and program for the whole migration was started in 2018, I think in February or so. And in late October, we were completely done and those Apigee VMs were shut down.
All right, since I have the mic, I'm going to ask one other question. So products that are built on NGINX competitive like Kong, did you look at that at all? And was the reason why you didn't move forward with them?
We looked at those a little bit, but we didn't evaluate those very intensively. In our opinion, Kong would have made it easy to get started to achieve basic use cases, since it has a nice API and a nice GUI. But especially those configuration management aspects, from our perspective, were easier to integrate into vanilla NGINX. So I've spoken about the configuration management inside source code, and from our experience, that was easier with NGINX vanilla. And of course, if you look at the Kong source code, you have like 50,000 lines of Lua code, and our solution is like 1,000 lines of Lua code. So it makes it easier to maintain on the other side. All right, if you have any further questions, just give me a shout afterwards and come to me offline. Thanks.
Thanks.